Bismillah Rahman Rahim. So in this slide, basically we will discuss the introduction of the standard model. What is basically the standard model is basically a framework which describes the fundamental particles and the forces of the universe, you can say. This is the standard model which defines the all the fundamental forces which are in the universe and the forces between the fundamental forces. So the discussion and the framework of this thing is known as the standard model. Here you can see, and you can see here the standard model basically includes the quarks. Here you can see are the six quarks, and also four carrying particles. You can see these are the four carrying particles including gluons, photons, Z bosons and W bosons. These four are basically the force carriers, you can say, and these are the quarks, you can say. Up quark, down quark, jump, change, top and bottom. These are the six quarks, and quarks and forces, they all work together and to build everything in the universe. Everything in the universe are made up of these quarks and the force carriers, and the framework which describes this model is known as the standard model. Okay, so this is about a little introduction about the standard model. Another particle you can see in the standard model is this Higgs boson. What is basically the Higgs boson is? Higgs boson is actually the particle which gives mass to the all fundamental particles. This is the Higgs field, basically, you can say. Standard model also basically explains the behavior of particle productions in high energy collisions, such as those high energy particles produced at LHC, and some properties of quarks and some leptons are also including in standard model. You can see here are three leptons: electron, muon and tauon. These are actually the three lepton particles in the standard model. Additionally, their neutrinos as well. So this is electron, their neutrino is electron neutrino. This is muon and muon neutrino. This is tau and tau neutrino. So these are the corresponding leptons and their corresponding neutrinos as well. So combination of all quarks, leptons, their neutrinos, all four force carriers and a Higgs particle, you can say, which gives mass to all fundamental particles. This framework is known as the standard model. So this is all about the introduction of standard model. In next coming videos, we will go through the fundamental forces and we will discuss later. Till then, take care and Allah Hafiz. Thanks for watching. Stay tuned with us. Bismillah Rahman Rahim. So in today's video we are going to discuss fundamental forces, all the fundamental forces which are in nature. So basically there are total four fundamental forces which are in our nature. The first one is the gravitational force. Whereas gravitational force is concerned, this is the weakest force in all the four forces, and this is a long range force because you can see a long distance gravitational force is expanded. So this is the first one, is this is the weakest force, and this is the long range force, and this is the actual force which governs the motion of planets, between stars and between galaxies. So the motion of planets, stars and galaxies, all the motion away gone. So gravitational force is the main concern, and this force is negligible at particle level. Okay, because this is a long range force, macroscopic level, so that's why this force is negligible at the particle level. So this is all about the gravitational force. The next one is the electromagnetic force. Whereas electromagnetic force is concerned, this force acts between the charged particles. What's charged particles? You know that this force is basically responsible for the phenomenon of charged particles like electricity, magnetism, and the phenomena of light. So this is all the phenomena of charged particles in the electromagnetic force: electricity, magnetism, and the phenomena of light. And this force, electromagnetic force, is infinite in range. Understood? And this force, electrostatic force, electromagnetic force is stronger than the gravitational force. You know that the gravitational force is the weakest force, but the a long range distance, whereas electromagnetic force is concerned, it's infinite in range, and but this force is stronger than the gravitational force somehow, you can say. Now move on towards the strong force, the next force. This force, strong force, is basically acts only a short range distance. Like example is inside atom between quarks. Okay, so between atoms, quarks, you can say the strong force is responsible and only for short range distance. How much short range distance? Around about femtometers, 10 raised to the power minus 15, which is absolutely inside atoms. So that's why strong force is responsible between quarks and between atoms, a short range distance. And this is the actual force which binds the quarks together in proton and neutrons, as I told you before. And also the strong force is very crucial for understanding the jet production in particle collision. And you know that what is jet? Jet are basically sprays of particles resulting from the hydronizations of quarks and gluons. Okay, so this is also very critical for understanding the jet production in particle physics. Now move on towards our last force, which is the weak nuclear force. What is weak nuclear force? Weak nuclear force is responsible for the radioactive decay and the neutrinos interaction. All right, and this is also act in subatomic scale, like small scale, to the particle interaction in high energy physics. So these are basically the four fundamental forces in our nature. In next slide we will go further discuss about the particle physics. So till then, take care and Allah Hafiz.